Hey everyone, we've finally released the Loop Cut feature for the Expert Curve modeling add-on. We know that many have been waiting for it. In this video, I will show you how to use it. To use it, you will also need the Curve Work add-on, as we used functions for the internal algorithms from it, which are large and difficult to port. As you can see, we managed to implement both manual and interactive versions of the function. This feature can open up a lot of new modeling possibilities that weren't there before. Enjoy watching. Let's take a look at how the new Loop Cut feature works. We go into segment mode, and here it is in the segment panel. Let's select a line from the segments. It's closed. This is one of the methods of operation of this function, the method on closed loops. Here we have 4 segments selected in a closed line. One of them is active. Now these segments are divided into 2 parts. This function divides the segments exactly in half along the grid line on these segments. And now you can manipulate the curves. Well, of course, you can delete it and continue working. You can also select all segments horizontally and make a loop. It's important not to select unnecessary segments, and the more segments you select, the longer the function will take to execute. Let's try on a cylinder. Look at the cylinder. It has curved lines when we use the Loop Cut function. By default, we have points left here to repeat the bend to maintain the bend. Let's say we had a more complex curve here. Let's use the Curve Work add-on. We've complicated the shape a bit, so let's do a loop cut now. These points are left to the discretion of the user, but they are not always needed, and you have 2 options. In the simplest bends, they can be dissolved manually. Just don't select the edge points of the curve. Or you can open the tab next to the Loop Cut button and check the Dissolve Points box. Then they will always dissolve when you perform the Loop Cut operation. So if you need to keep the curve points, don't turn on the dissolve function, but in most cases I leave it active. Also, note that on flat surfaces, the default algorithm dissolves points regardless of the checkbox. But this is only if the grid is uniform. In this part of the cylinder, the points are not evenly spaced. This is due to the fact that it is quite difficult to guess which bin the user is using. When using loop cut on a single segment, you have a checkbox in the lower left to invert the split. Let's now see what happens if we select not all segments, but only one on the cube. As you can see, we have a loop here on the part that we highlighted, but what do we have here at the junction then? Here's what it looks like. The segments you didn't select kept their curves, and the split segment got new curves. So now, the possibilities of working with ECM have expanded. The thing is that each individual segment has the same resolution as all the other segments, so there will be a grid offset at that point. Using manual resolution control, you can change the resolution on new segments to the level required to merge the mesh. In model mode, it will also be merged. But unfortunately, this only works on odd resolutions. If we make the overall resolution even, then you probably won't be able to manually select the number for connecting the grid in the resolution. Also keep in mind that you need to close the mesh correctly. With such sharp ends, the triangular segment will definitely not close this mesh without overlapping. Another option is the ability to sequentially select an unlimited number of segments without a loop. This is if you select 3 or more segments sequentially. This unselected segment will also retain its curves. Let's now consider this case. I think you've already guessed that this function will not be able to divide the triangle. This is primarily due to the fact that the grid inside a triangular segment is constructed using a completely different algorithm. Therefore, quadrangular segments should be distinguished separately. In the previous version of this feature, we couldn't select segments as separate islands, but now it's possible. The only normal segment sometimes requires manual turning when working on a plane. At the same time, here the triangle also has its own curves. To connect this section correctly, You need to remove the triangular segment and close them one by one like this. The grid here will be perfect. Let's create a second cube. Let's select successively closed segments on two cubes. As I said, the more you segment, the longer it will take to complete the task, so it might make sense to do it separately. This can also be done in parallel by selecting elements in a non-cyclic manner. Let's now see how manual factor change works in an interactive mode. In manual mode, you have a factor down here. It's better to enter the numbers manually because with each change it recreates the loop cut with the change cut location. This is any number from 0, 0.5 to 0, 95, but I do not recommend setting numbers too close to the edges. 0, 5 is the default middle of the segment. In the manual version, due to recreation with each change, this causes a delay. Interactive execution of this function is launched by pressing the hotkey Ctrl-R. When you move the mouse left or right, the value of the factor that is displayed at the bottom left changes. Also, the place where the segment will be divided is displayed as dots on all the curves that will be divided. To apply, we use the left mouse button, and the right mouse button is used to cancel, while the selected segments will remain selected. When splitting a segment horizontally, we still move the mouse left and right. And as you've noticed, if the mesh is curved, the loop cut will also be curved. This can help create a middle bend between the top and bottom curves. If you don't need this, you can simply switch the point type to vector mode. This feature opens up new possibilities for ECM modeling. If you liked it, please give it a like. Thanks for watching. See you in the next video.